I think we are good to start right now. Welcome, everyone. Welcome to the June meetup of Women in Comparison Tools. This time we are having our new speaker. Her name is Angélica Moreira. She is a fourth-year PhD candidate in the Computer Science Department at the Federal University of Minas Gerais, UFMG, and she is also currently a research intern at Microsoft Research. During her PhD, she has been awarded the Microsoft Research PhD Fellowship for the year 2021 to 2022. She has also been accredited with Facebook Emerging Scholar Award last year, and she has also received an award in Student Research Competition at CGO 2021. She is a member of Compilers Lab, where she is advised by Professor Fernando, and she received her master's degree in computer science from UFOP and the BSc degree from PUC Minas. Angélica's research interests are in pursuing the design and implementation of techniques that reduce program binary size and make them run faster on heterogeneous architectures. Her research focuses on combining machine learning and compilation techniques to achieve the goals. And her dream is to contribute to the better world through the development of science and technology. On a personal note, I met Angélica when I was looking to recruit some reviewers for the Artifact Evaluation Committee in CGO, where I was very impressed with the way she was not just doing her work to make sure that the artifacts can be reproduced and to find out if there were any gaps. She was also helping the authors who submitted the artifacts and also the peers who were working to evaluate the same artifacts. And later, I found out that she was in Microsoft Research doing her internship. So, Angélica, we all welcome you. The stage is all yours now.
Many thanks, Sylvie. So, hi guys, my name is Angélica, and today we'll talk about the statistical profiling and why one should give it a try. But before I start, I know Juby gave an introduction about me, but I want to talk briefly about myself. And I'm a geek girly girl from the beautiful city of Belo Horizonte. Translating this name to English would be something like beautiful landscape. So if one day you come to Brazil, please add Belo Horizonte to your list so you can see with your own eyes how beautiful it is. I wasn't prepared for you being talking about myself, so I had this, I'm advised by Doctors Fernando Pereira and Guilherme Ottoni, and for the past 3 years and a half of this journey, I've been working with the LLVM infrastructure, and the main project that I've working on is in regards to that code elimination, basic block reordering, static branch prediction, and currently I've been interning at Microsoft Research in the team that maintains the Mystical project, and my work there is designing and developing an MLIR compiler for generating C2 the code for the optimized primitives for inter-GPU communication. You guys can check out how cool this project, the Mystical project is at their GitHub webpage. Now that you guys know a little bit more about myself, let's dive into some basic concepts for this talk. Beginning with the difference between branch prediction, probability, and frequency. A branch prediction is a yes or no answer for the direction of the branch at a given moment. For instance, looking at this snippet of code, a branch prediction algorithm might say that branch B1 to B2 will be taken, which also means that branch B1 to B3 will not be taken. A branch probability is an estimate of how likely branches to be taken. And in this case, an estimate might predict that branch B1 to B2 has an 81% probability of being taken, while B1 to B3 has 90. Finally, a branch frequency is measured how often a given branch is taken. And in this example, let's say that basic block B1 executes 80 times, in 65 of which each branch should be 2, and the other 50 times each branch should be 3. Thus, what is soft-based branch prediction? It is a technique that predicts the behavior of branches based solely on program code analysis. For example, one question we might want to answer is which way we are more likely to go. This analysis could be done dynamically, involving execution of the program, or statically by only looking at the source code. In this presentation, we'll be dealing with static branch prediction technique, but I'll go over some other techniques too, so you guys will get to know the others. To perform predictions, one needs to profile the program, that is, observe how its execution behaves. As I mentioned, however, static prediction is a bit different than the usual way to predict branches, which is performed by dynamic profiling. Typically, in dynamic profiling, one executes the program and observes its behavior based on different inputs. Then predictions can be made based on those observations. We can also compute the edges probability from the edge frequencies. Like you can see, we have 75 if a person would be like a dog person for a given input, and 25 for a cat person. This is typically implemented in a few ways. There are sampling-based approaches for the dynamic profiling. These implementations run the program, while sampling is a subset of instructions in the program. It then collects execution information for this subset of instructions, hoping that they are enough to model the entire program's behavior. This is what a sample record looks like when using Linux Perf2. The alternative to sampling is instrumentation-based profiling. In this case, one injects additional profiling logic to the program's code, which then records its behavior as it runs. Sorry. As you can imagine, however, this technique has much higher overhead costs in terms of CPU and memory. Additionally, it is much more intrusive to the deployment process, as it typically involves rebuilding the target binary multiple times. Speaking of intrusiveness, that is precisely one of the motivations for using static profiler. So why use a static profiler over dynamic profilers? There are scenarios in which the acquisition of profile information from representative inputs is difficult, maybe because of hardware and OS restrictions, for instance. Plus, sometimes it can be impossible to gather this information. For instance, in end-user mobile apps, where we need the user to agree to allow us to collect some data. In static profiling, we try to model the program's behavior only looking at its code. That means no execution whatsoever. This is really cool. We then try to predict the likelihood of a given branch executing based on the static observations we make. There are two main ways of building static profiling: heuristic-based techniques and machine learning-based ones. As an example of the first one, imagine we have a code such as this one. And in this case, we have an error handling two-way conditional branches. We can devise an heuristic that assumes the error path executes much less often than the no-error run, which seems reasonable. Thus, we could make predictions such as this one, which deems the error path cold, while the no-error run is hot. LLVM has a built-in algorithm for static branch prediction. It is based on some of the earliest work in this area due to bow and arrows. GCC also has one implementation that is based on a mix of bow arrows and bow and arrows. However, heuristics are a very ad hoc solution, typically modeling some simple branch patterns. Additionally, it relies on compiler developers coming up with these clever heuristics, which are far from trivial. Sorry. Therefore, in this work, we instead perform machine learning. There are a lot of works that perform machine learning statistical profiling. The way this techniques works is by collecting a corpus of programs and collecting some statistical features to describe them. Then recording their branch execution behavior. Then one trains an ML model based on this recorded behavior. And finally, one has a new unknown program. They can have this ML model assign probabilities to each of these program branches, effectively creating a statistical profile. There are some works in this machine learning approach technique, and the seminal work is this one from Calders, and our work based on Calders. And recently, there is this other project that it was built on top of LLVM infrastructure. Since I started to show you guys the Vespa project, this paper, the Vespa one, I'll get into the Vespa project. The main goal of this project is to optimize binaries, taking advantage of some statically inferred profiles by a machine learning model. We were inspired by the Calders, the seminal work of Calder, the 1997 one, which used the classification model to statically predict branch directions in program. However, we approached the problem from a different angle. We model it as a regression task. And that is the reason we called our project as Vespa, which is short for Vintage ESP Amended. And since Calder's approach is called Evidence-Based Statistical Branch Prediction, or ESP for short. The first work in this direction, it was this one made by Calder. And what difference from our work is that back then the authors used decision tree and neural networks, the classifier version of them, to perform statistical prediction. And they trained this model to perform classification on branches. So they say, well, if a path is likely to be taken or not. In our case, we have probabilities. So we say in which frequency and which probability a path will be taken, not only a simple yes or no answer. In this work, we implemented a static inferred technique on top of the both binary optimized, and both typical usage looks something like this, where one runs the target program with a profiler enabled. This profiler is converted to both standard input format, and then both optimize the binary based on counters collected by the profiler. Our technique, on the other hand, analyzes the program's code statically, extracts a few code features from it, and feeds it into a trained predictor, then optimize the program based on those predictions without having to run the target program. Alternatively, to run the program, our technique follows some steps. After the program is disassembled, we extract 56 features of its branches. We perform some pre-processing to create these features. And we use then to run, to either train our deep neural network or have then this neural network to perform predictions for each of the branches if it is a unknown program. But how do we collect these features? Well, we implemented a pass on top of the both optimization pipeline. This pass runs once the binary has been disassembled and its CFG has been constructed. The pass analyzes the program's control flow graph, sorry, collecting statistical features about the program. Some of these features were processed by Calder's original work, while others were devised by ourselves. I know at this point you must be wondering, but which features? I know that going over all the 56 features would be like cumbersome. and would take like forever, but I will show you guys one of them. And there are a few features which are highly significant, such as is loop header feature, which determines whether a branch is a header of a loop in a program. That would be true for this one, but false for this one. Oh no, sorry. And there are 55 more features to go over. Finally, when optimizing a program, our model outputs predictions for each of its branches, but how exactly do this look like? Well, as mentioned earlier, the model attributes an estimate for the probability of each branch to be taken. However, both performance optimization decision based on branch frequencies, so we need to have an engineering solution for this and to determine the execution counters. And we found the solution by using the solution to go from output probabilities to meaningful frequencies using a technique proposed by Vu and Laros. And this algorithm works by first computing the frequencies for each basic block and adds in a function interprocedurally based on the branch probabilities, and computes from the start of the function and block, and then propagates the frequency to calculate the frequency for all other blocks and edges of the program. However, this algorithm provides only an estimate of the frequencies for each block, and we needed a validation step to assign the function's frequency. So we calculate the entry and exit flow for a function, and we check if this matches an error measure of 20%. If it doesn't, like if it isn't on like between this error measure, we disregard the computation and we mark the profile as stale or unusable for that function. And however, in performing, such profile has some inherited drawbacks. One of these is dealing with indirect branches, since this cannot have their targets inferred statically. It is impossible to model their behavior at compile time, and this adds some imprecision to our implementation. Similarly, indirect function calls also cannot be reasonable about at compile time, which adds imprecision to the interprocedural frequency inference. Now I'll show you guys a little bit of experiments. And our hypothesis in this project is that a binary optimizer equipped with a static profiler can still provide performance benefits over the baseline compiler binary. Thus, let's see how our technique compared to other approaches to generate high performance executables. First, let's go over our experimental setup. We trained our DNN model on a set with 243 programs. And from this, we had the corpus from a little bit more of 2 million branches to a conditional branches, but we only use a little bit more than 500 two-way conditional branches because they were associated with provided info, since we were using a sample-based approach for here. All binary used in training and as a baseline were compiled with Clang 12 at the time with -03, and 80% of the collected branches were used for training and 20 for test and validation tasks. And for this presentation, we'll go over results from only one research question for my paper. But if you like curious about all the implementation, all the things behind the Vespa project, please read my paper. The second research question for my paper was whether binary optimized with static profile built by Vespa would show any performance benefits when compared against the binary optimized only by the compiler and one optimized by both dynamically. Our comparison baseline is the original binary optimized by Clang at its highest optimization level. We also compared against several other candidate binaries. The first of them is a binary built using both with its typical dynamic profile. The second one is the same as the one before, but we removed all unnecessary information to be more fair with Vespa and allowed only two-way conditional branches there. The third one is our approximation for Calder and the profile information inferred by this approximation. And the fourth one is a binary built using both with the static profiling using the heuristics due to rulers. And some trivial predictor like the base that predicts 50-50 probability split for either direction. And for our null hypothesis is this both without profile information at all. So we could check if the gains were coming from the profiler and not from any optimization that both could be performing automatically. And we also have the other trivial, the never and always that predict 100% to either direction. And finally, we have both equipped with Vespa, which indicates the binary built using our technique. Here we have the runtime results for the Clanks have been compiling itself. We can clearly see that while using both with a fully dynamic profile vastly outperforms the other, Vespa still provides a significant speed up over the static techniques. Besides, we can prove that we are skilled if we compare against no profile information at all. And that using profile inferred and approximation of Calder, we are better. Here we show results for the optimized binary, the MySQL. The input is the OLTP point select benchmark from Suspend Suite. The same behavior occurs here, where both using a fully dynamic profile is far better than the other binaries, but with Vespa, still providing relevant speed up over static alternatives. And the experiment discussed in this research question shows that although our static profiler is still far away from the dynamic profiler, it does deliver considerable speed ups on top of the optimized code with -03, and that we are better than our approximation of Calder that uses Vespa's infrastructure and Calder's features, and that we are skilled if we compare it with both without profile information at all. So thank you guys for watching my presentation. And this presentation, you guys learned a little bit about what is software-based branch prediction, some types of branch predictions, how you could perform profile, use machine learning as a tool to help you in the task of generating static profiling, and how we can get branch and block frequencies when you only have probabilities. This project was sponsored by Facebook, the Meta Research, and it is currently sponsored by the Microsoft Research due to my fellowship. So thank you guys. If you have any questions, I'm open to questions.
Thank you, Angélica, for such a wonderful talk. I think I particularly had a lot of things that I learned today about static profilers. So thank you for sharing all that. If anyone has any questions, you can unmute yourself. Feel free to turn on your cameras if you want to, and you can ask your questions. And you can also post your questions if you want in the chat.
Hello. Hello, Angélica.
Hi.
Hi, I'd like to know what tool did you use to instrument the code, and how do you eliminate the effect that the instrumentation has on the performance of the binary?
Okay, the tool we used was perf, and sampling profiles. This kind of tools like doesn't add too much overhead while you're doing this. Like in the task of using sampling, it's like the overhead is too small. So I wasn't doing full instrumentation. I was only using a tool that collects this while running. So it doesn't add too much overhead. If I was instrumenting the binary itself, it would be.
Okay.
Is there any other question that someone wants to ask?
There's one question here on chat. So, are any of the extracted features specific to binaries? Would the same method work on the LLVM IR or on the source language, or is it at the source language level?
It works both. They are not tied to the binary. As a matter of fact, they were more difficult to extract in the binary. It's easier to extract on the IR level. There is this Facebook project, a meta project that they did this on top of the IR. They were able to extract more stuff, and I'm migrating Vespa to LLVM IR too. So in the future, I will know. Hopefully, I will have like better results because I'll be in another stage of the pipeline.
I also have a question regarding branch prediction. So, I mean, I'm not sure how much does it matter to ensure that whatever results your machine learning model or the existing, traditional techniques which people adopt to write algorithms for branch prediction matter towards correctness. So, do you have any thoughts on that?
So when I started the project, I was trying to make the accuracy of the prediction more close to what you would observe in dynamic profiling.
Okay.
But it was like difficult to do this with the set of features. Like it's difficult to map a set of features that will make a cluster of branches in such a way that, for example, a set of feature branches that will say exactly that a branch will be taken with 92% of probability. It's difficult for generalize this for a bunch of programs. The same set of feature could say for you that you have like 10% or 5%. And when you try to clusterize this, you don't have like a good function that will give you like this value too close to the real probability, because they don't generalize. Like for one program, it's easier to do, but when you have like a lot of programs and trying to predict different programs, it was kind of difficult. Like for me, I didn't found a way to do this in a better way.
Okay. And also another follow-up question that I had in my mind was about the feature extraction. So since you said that you collected or started to build a machine learning model on the basis of a set of programs, and in the result we saw that there was a point where Vespa could improve the performance for the baseline case. However, it's still not able to beat the performance in terms of speed up for some other performance benchmarks or something in comparison to Bolt. So do you have any like analysis on like what could be improved in Vespa in the future, so we can, your project can aim towards bringing up more speed up for those benchmarks?
Yeah, besides trying to figure it out, another set of features that would help us to generalize, but we are seeing that this is kind of difficult because people in a lot of different research groups are not being able to do this so far. Beside of that, we could like improve the indirect branches, because currently we have like an unbased solution. Like we do, for example, for switches, we do probabilities one by the number of cases, and we could implement one solution for this. And another one is the way we convert probability to frequencies, because for some specific kind of shape of graphs, the CFGs, they don't work quite well. The technique doesn't work. So we need another solution for this. So we would not like disregard a lot of profile information, because there are a lot of profile information we disregard because of this count that this computation doesn't match the error measure we put here.
Sure. And about the features, feature extracted using your machine learning techniques. So does it matter? Like I'm not at all a machine learning background person yet. So I'm just curious, like, how do you guide your machine learning model to extract the features? Like, is there something that you have to control the knobs, or is it something that you just give the programs and let it run to collect all those 56 features that you got? Or do you have to do some manual analysis on the underlying programs to guide it in a certain way?
Oh no, I use it like a recursive feature elimination. I understood your first I did this pass that extracted all this kinds of feature, like in regards of domination, whatever. And I use a recursive feature elimination technique to see which features were, so it is automatically, it was like auto ML. So it automatically discover which are better, and without myself doing this. Like at the beginning I was doing by myself, but it's too much program, too much analysis. So I discover AutoML and
that's what I wanted to know. Like, otherwise it's going to be a very challenging task to figure out. Maybe the manual analysis can find something, just sitting in the corner, but again, that's not worth it, I guess. So yeah, thank you. I'll come back with more questions. I think there are some more in the chat now.
Yeah, so we have another question here. Is there a good way to reverse engineer the model to see if it found some heuristics that we should backport to classic compilers that do not use any ML in their optimization pipelines?
So
this is a very good question.
My advisor made for me some similar question, because we know that it is really cumbersome to add this at the whole pipeline of a compiler. So he gave me this challenge at some point. I don't know. I don't know how to answer this so far. I hope I will know by the end of my PhD, but I don't know how to go backward. Like if it was only a decision tree, like we had this decision tree at the beginning, so you could have like take the set of yes or no answers, so the path of if and else from this decision tree, and translate this rules in something that could be written as heuristic. But for this machine learning using neural network is the blurry stuff. So when you want to do the reverse path, so this is difficult. So I'm trying to figure it out in a way, or in a simple way to do this, like, because there is a way, it must have, but so far I don't have this answer. I'm trying to use like a simple model to put in this place, like decision tree and KNN, because it's like easier to translate in rows. But yeah, thanks for this question.
Cool. There's another question by Andre, which says, could this be made a part of O2 and O3 optimization levels? And how long in percentage does it add to compilation time?
I did this on top of, I don't know if it could be, okay. It could be made part of O3, because I did this on top of O3 and I got on average 5.5% on my set of benchmarks. It could be. Compilation time, it adds a lot. Like it was like in my paper, I described this like it is one of the drawbacks of using my techniques because it adds a lot of regression in compilation time, although you will have like speed ups on the execution. So you must see what you can pay to make better for the project. But yeah, that is the answer.
And another question from Andre is, can it be used to augment FDO for parts of the code which are not exercised in the scenario when capturing the execution profile?
Yeah, yeah, it could be. I saw like there is this there is any study in regards of this. I can share with you later. I forgot to there is a study made by the Meta group, the Meta research group. They did some studies in regards of this. It's public.
Angélica, for my benefit, what's FDO?
A feedback-driven optimization. It's other way to say profile-guided optimization. Sorry, guys, for coughing all the time. I'm recovering.
Take a moment if you need to have water.
Yeah.
Go ahead. So I think the follow-up question which came up like that was a very interesting questions, by the way, to everyone who are following up with very good questions here. So yes, I think that problem is very hard, as you mentioned, to reverse engineer from whatever your machine learning models are suggesting us to develop the heuristics. So compiler developers can directly adopt those. But if that happens, that would be very, very great and a very valuable contribution besides whatever you're already adding up to the compilers. My question was about the usability of the current project that you have worked on. Like, how can one adopt Vespa in their work stream and like how flexible is it to use for just do some static profiling at different times, because everyone wants to do static profiling for different parameters and so on to find out maybe the hotspots which are consuming a lot of energy, sometimes maybe hotspots for some binaries where we want to see the code size is getting bigger, the calls are getting quite a lot. So how can we use Vespa in general?
So currently Vespa is tied to both. It was built on top of both, so it's tied to both. So one needs to use the both version and use the specific flags to extract the features and take advantage of all the implementation of static profile that is there. Not the upstream one. Hopefully it will be in the upstream when it passes through all the review part. Currently is only my GitHub, but I was promised that would be inside there at some point. But I'm also preparing another version that will be disattached from both, and it will be on top of the LLVM infrastructure. So the one that I told you that will be tied to the IR, because I want to see in another level what happens when we use Vespa instead of the coherent heuristics, because I compared against at the end, but I want to see what happens at the beginning and with other optimizations that are available at the LLVM infrastructure.
And what's the reasoning behind that you want to perform static profiling at the IR level? Like you're basically shifting forward. So how is it going to help?
One thing would be like it's easier to extract the features. So I will have more features, and so I will have a new set of features, and it's easier to generalize and it's and to apply to another optimization. So yeah.
Sure. Yeah, this is very cool. If anyone else has more questions, we still have time. But otherwise, I have some non-static profiling questions as well to just drive this conversation in a more informal way so we can get to know our speaker in a better way. So feel free to ask those kind of questions as well. To just give it a starter, I can just move forward. So I think we have asked this question to all of our speakers because we're very curious to find out how, you have landed up in the compiler space. Like, what was your first compiler project like, and how did you find about compilers at first place?
So my first project was building a compiler. Like, I think almost everyone in computer science, I don't know in the US, but in Brazil, everyone in computer science has this class and we need to build a compiler. So
Nice.
I was fascinated by building my own compiler in Java. I was fascinated by doing my own Angélica compiler. It was the name, Angélica compiler. And I wrote a lot of different stuff. And the language was Angel. And I loved this project. Like, I felt in love at the time.
Yeah,
It was really cool.
Yeah. I mean, it's incredible because it's not very common that every university or every undergrad program would offer a compilers class. So this is very incredible to know, like your school was offering it and you found it very fascinating. So awesome. And what made you chase, a doctorate program in compilers? Like, what was it like? Like, why you always were shifted or pulled towards compilers in general?
So when I finished my master's, I went to work at the industry for a while.
Mm-hmm.
And back then I was like, I need to go back to school because I am a researcher from within. I need to go back to school. So I went back and I talked with this professor, Professor Fernando, my advisor. And I was talking with him that I wanted to be like the best software engineer I could be. And I knew that if I knew as much as I could about compilers, I would be. And we started to talk because of this, because I wanted to be like a badass engineer. And for me, being a badass engineer, you need to know, like, dive into compilers and know everything. Like, because of this class I had when I was in my bachelor's, like, I knew, because after having this class, I learned a lot about programming. Like, when I started, I wasn't that good, but at the end of this class, like, I was like, oh, I'm badass. Like, this way, like, I was so like skillful. Like, I learned a lot by doing my own compiler. So I knew that if I needed to be like an excellent software engineer, I need to do something in compiler area, because then I would learn a lot.
Very cool. I mean, I can see like you are so passionate about it. But I think while PhD or any grad program or any, such intensive projects that we move forward with, they are very much helpful in terms of like we gain a lot of knowledge and it improves our skill set and so on. But PhD in itself, brings up a lot of emotional, mental, and technical challenges at times. So how has been your journey so far, in the past 4 years? And then before that, you were already doing your master's program. And how has it been for you?
So one thing, I think I'm like, I'm blessed to have like this research group I'm inserted, and my advisor who had challenges during his PhD, because he built this research group that it is like this family. Because I before I joined my research group, I had my own friends and everyone and so on and so forth. But after joining, I was losing my friends because everyone was like, you cannot go out. No, I cannot. I need to read. I need to write code. I need to read paper and write stuff. So no one was understanding, because doing a PhD is like a lonely job. Like it's like you're surrounded by a lot of people, but it is a lonely job. So, and by being inserted in a group that it is like so tight, so friends, so we have a lot of bonds. We stay like at the university through like midnight and go and just continue studying and doing stuff and having fun. So by having this research group together with me, I have all the friendship, all the friends, all my allies, because I'm a girl inserted in a men's world. So, and they are my allies. So they are really cool. So I'm blessed to have this research group. But I know that from times we are overwhelmed with a lot of stuff from PhD, and yeah, it's challenging, but having a lot of good friends, or some of them are like family to me. So yeah, having this is really good.
Yep. No, I think that's wonderful that, you know, your friends could also recognize that this is the demand of your dreams that you're pursuing. How is it like in your lab, like how big your lab is in general, and how your group works together? And like, I can totally see that, you know, from the thing that you were talking about, like you feel a lot of support being given from your advisor, from your group and so on. Like how big the group is and how does it actually function? Because the experiences are very varied for everybody, you know, who is in a different grad program at different schools in different countries and so on. So it would be just nice to know, you know, for people like, okay, you know, this happens in so and so university.
So our research group is like, we are friends that hang out. Like we not only talk about our research project, it is like a nerdy group. Like when we go out to eat burgers, we talk about compiler optimization all the time. This is funny, but we have some laugh in regards of this. And we go out together, we do a lot of stuff together. Sometimes we research in peers, like we do our research goals like together, and we help each other too. So it's really cool. We have this like when someone needs to write a paper, we have everyone helping each other to correct the paper. So everyone is verifying if there is any errors and stuff. So it's really cool. Everyone help each other, and yeah. And we are like a big family, like extension of the family, because some of the guys who are here in our lab, they left their families in their cities, they travel to live here. So we are the extension of their family, and we try to do a lot of stuff together. But it's a really cool group, but it's a small group. Like I think currently we are 8. So it's a really small group, but not everyone is like a graduate student. Some of them are bachelors, so they are assistants, researchers, and some are masters, and we are the only 2 PhD students, me and Michael. Michael is the new one, so I was the only one before. And then Michael just joined us. So yeah, it's a really small group, but we hang out together. We do a lot of stuff together. It's really fun.
No, I think that's great. Doing fun during your grad school is the most important thing. No one should miss out on that. And if your group turns out to be that, where you can, you know, in fun talk about compilers and just have a good family kind of environment, that's great. That's a healthy environment.
My advisor has this fun with programming languages. Not so fun sometimes, but he has this fun with programming languages that it sometimes is really interesting.
Cool. I'll just take a moment and allow any other attendees to ask questions.
Hey, Angelica, I had a question for you. So you started off as a classic compiler engineer, right? And then you added a little bit of ML to your compilers. So now where do you know, are you getting more interested in the ML aspects of it, or are you still a classic compiler engineer? Where do your interests lie?
I think after getting in touch with ML, I will never be again the classic one because I learned the new tool, like I learned that I can use something
Can't go back.
new. So I have one tool set on my backpack myself. So yeah, so I will be always a mix. That's the reason, like at the beginning of my presentation, I told that I'm working in this such a cool project that is MLIR based, because I work with some workloads for machine learning in this compiler, and I use the MLIR infrastructure for building this compiler. And this is such a cool project. And I started to learn that I like this mix, but I'm not like, I will not say that I am this machine learning engineer, because I know that someone needs deeper knowledge. But what I learned, I will use as a tool set for improving my compiler engineer technique.
Very cool.
Are there any more questions from the attendees? If not, I have another one. So since you started to write your own compilers through your undergrad program, and then you came back to pursue your master's and so on, how did you narrow down your problem to this kind of a research work where you got more curious about binary optimizations and doing a lot of work on the static profilers and so on? Okay.
When I joined my devices research group, I told him that I wanted to work as a software engineer and with hardware. So he were helping me, guided me to go to something that I could work with some knowledge of hardware, so close to the binary, close to something of the machine, and improve and open my knowledge on top of this. So that's the reason I end up following in the branch prediction and then software-based branch prediction.
And I would assume that also required you to learn a lot more in-depth computer architecture details as well, or is it all independent of the architecture part?
It is independent, but I needed to learn and I needed to know, because since I'm working with binary, I need to understand that the x86 assembly, and then because I do the disassembly part, I need to understand this part, and yeah.
Yeah. So the reason I was just curious about this narrowing down problem to pick up your research topic was because it gets very harder, during our PhDs to figure out exactly what we want to solve, what is the real problem that we are very interested in. Of course, we have our advisors, we have the community to talk to when we go to conferences, but what is your, take on like what really helped you, or what in general could help somebody else, who is in their, let's say, their first or second year of PhD program, or maybe students who have not yet started their PhD, they're always overwhelmed with this one feeling like, oh, I don't know what I'll be working on. So did you know anything before you started your PhD, or was it during the PhD that your advisor guided you towards a problem?
Yeah, it was, I didn't know before. If you read the project that joined my PhD, you will see like a completely different thing that I end up working on. My advisor was wise and guided me, like giving me research papers, and then he had this feeling that I was like liking more from one area instead of another. And he gave me the flexibility to talk with him. I don't like this thing. I don't like. I think it's easy. It was easier for my advisor because back then he had like 3 PhD students. And it was easier for him to talk with us all the time. And since I was joining and the other ones were graduating, so I had him all for me. So he was able to help me in all the stuff. But I also had a class from a professor at my university, and this class was for guiding our mind to find the correct project. Like this class was it was designed for us to build what we want to do during our PhD. So during the class, I was learning, and at the end, I had some research questions. Like I started with nothing, and then at the end, I had some research questions. So this class was good for me.
Very cool. Yeah, this is the first time I'm at least learning that there are structured, classes as well to guide you to choose or ask the real research questions. That's very nice to know.
Besides sharing your work, is there any action that you normally do in order to incentivize more women to join computer science? And how many % of your original class was composed by women?
So currently, I'm not so engaged in this in women's space. But back then, I was like, my advisor would disagree with me because every time I try to pick up women and bring to our lab, like every conference, every place I go, I try to talk with a lot of women, as much as women as I can, and I try to say to them that I love computer science, that would be a really good area for them, and I explain to them a lot of stuff. I do this like a regular basis, and my friends, if they are here, they know. Like other day, we went to the museum. I found a girl there that told me that just joined the same university that I stood, and I told her, you need to change your course, because she was like unsure about her course, and I was explaining her that because of what she told me, I was explaining her how great she would be in computer science, because she showed me like she's skillful and she's able to do a lot of stuff. So I told her about this and switched my contact and so on and so forth. But I want to be more engaged as I was in the past. When I was working, I had this own group that I was teaching girls programming at the time. I want to go back to this, but during my PhD, I didn't have time for this. But I want to go back to this. I want to build this community or engage with another community. We have this group at my university. I want to be more, I want to be there with them. Like I want to work with high school girls and teach her how to program. I did that in the past, and I want to go back doing that because I think it's really important. Like they need to know they are good for STEAM area, because we are great, but we need to go back to the STEAM area. We need to have like 50-50 at least, my dream.
Yeah, I think you would make a very good mentor. So whenever time allows, after your PhD or towards the end, whatever time frame works, I think you should consider mentoring more students and bring them to the area of computer science, not just computer science, to the compilers as well.
Yeah.
So how are you trying to wrap up your thesis in your PhD? Like, what is it going to be all about? Is it going to be all about the techniques to perform binary optimizations?
Yeah, it will be about applied statistical profiling in a lot of set of tools and optimizations, and also a study in regards of staleness of profiling information, because we want to, because during the production time, people need to run a lot of dynamic profilings, and this is cumbersome process. So if we delay this process by using a statically features together with dynamic profiling, and then in some way we allow the user to delay the new dynamic profiling collection, would be better, because then they would like have this information there and optimize and guide all the optimizations in such a way. I cannot dive into this, but so far we are having like a median results. So if we have like awesome results, we will share. But so far it's median ones.
Sure. Cool. This is very interesting topic. And I'm sure you already have learned quite a lot, and contributed back to the community with your learnings. So you should continue to do that. And a very tangential question to what we have been talking about. The very catchy part was about your PhD fellowship, right? And also about your awards that you received in the recent past. So there's a very common misnomer about PhD fellowships when any international students. I'm sorry. So when international students, plan to apply for PhD fellowships in, Microsoft Research or any other industries around, they don't know what the application process would look like or how the funding situation would work for them. I mean, would they be given an additional funding, or would their current funding be stopped through the university? So can you talk a little bit about the process and also about what it took to write a very, intriguing application that you could make it to that fellowship program, because I know it is very competitive.
So in regards of preparing for the fellowship program, I would say write a good resume that like wrap up all the projects in some way and try to stand out your grades and all the extracurricular stuff that you made. And also during the project, try to be more succinct as possible, like something that you could catch the eyes of the person who is reviewing, because this, like as small as possible, because this person is reading a lot of applications. So if your project is small and you were able to say everything that you need to say in one page, it's also, or half of a page is better than, because since they are reading a lot of stuff, this would say like help them to decide if they want you or not, and put you on the go or not go continuing this process. And yeah, like I did that for the 2 times. I made the smallest project proposal I could, because I was gave this tip to do this way. And I was lucky in the 2 times that I applied. Like I applied 3 times for 3 different fellowship. The Facebook at the time, when Facebook was called Facebook, Meta was called Facebook, the Microsoft, and the IBM one. The IBM one, I committed all the wrong stuff. Like I didn't wrote a good resume. I didn't add a lot of projects that I made there with the description. I didn't put my grades there. I wrote like a huge project proposal. So I made all the wrong stuff. So a guy from IBM told me, you could try again, but try to make your resume stand out in some way. And you will find how to do this at the internet websites, like in career. You must write your resume as if you're like applying for an internship. And I was like, oh, cool. And he also told me, your proposal was cool, but it was huge. You need to make this as smaller as possible. And then I applied for the the Meta at the time with the smaller stuff, and I got. And then I applied for the Microsoft one, and I also got. So I think this is a good rule of thumb: a small project and a resume that stand out to you. Like, yeah.
No, this is very cool, and it's very admirable, because it's not easy to get even one fellowship at a time, and that too in the area of PL compiler. So kudos to you for getting 2 back-to-back fellowships from 2 different companies. And also, like when you picked up your project proposal, of course, that was something coming up related to your current PhD research. You also would, I'm assuming you would also have to dig up in the existing projects of those companies to figure out how you can connect the dots and then widen up the scope. Was that something that you looked up?
For the Facebook one, I didn't. For the Facebook one was the second one that I applied, and I wrote as if I was asking for a advisor to accept me. But for the Microsoft one, I did that. Like I searched on the web page what the umbrella of projects that could be similar to mine, what my project would help in some way. Because when you're like in the 3rd year, you need to have something, because of the Facebook one at the time was only for 1st years, so you don't have much, and there is no way you know how to make impact. At least for me, it wasn't like I didn't know how to make impact. But the 3rd year, I was like, oh, I will have like badass students from a lot of universities from Brazil competing against me, like because I was competing only with Latin America, different from the Facebook one. Facebook one was against everyone in the world, and the Microsoft one only with Latin America. And I was like, there is those tons of great students here, so I need to know what exactly to say there. So this was the difference. I was more mature in the Microsoft one than the way I wrote the proposal.
Awesome. Anybody else has any more questions? I think this piece of information about fellowships, about picking up research topics, and in general about pursuing PhD program, I'm sure that would help any grad students who are currently pursuing their PhD, or maybe the ones who are aspiring to enter into the PhD program. And I hope people can reach out to you in some way if they have any follow-up questions. Do you have any way to communicate that you would prefer?
I shared my email, so guys can send me an email, so I'm open.
Sure. What are your career aspirations after PhD?
To be a researcher, compiler area.
Awesome.
What
Be the coolest researcher I can be.
What other areas within the compiler realm do you have an interest?
I have interest in working with static analysis, because I do love static analysis, and I loved working in the back end of compilers. So yeah, this is me. I'm a back end girl who loves static analysis.
Awesome. I think I would make a last call to anybody who wants to ask any kind of questions. Please feel free to ask.
Did you consider applying the optimization on a real workload in a loaded server, like a Microsoft server or Facebook server?
I didn't use the Microsoft one, although my mentor there, from time to time, Madam, asks me if I want to use. At Meta, I didn't use, I tested, but not in the the production environment, I tested on their developed, not in the production one, because of the tools that I was using. And internship has this a small time frame. So when I was with the tool ready, I wasn't interning there anymore. So I needed to use the real world benchmarks that I could collect. So it was MySQL, the Postgre, GCC, and Clang.
Did you get any extra insights compared to the workload that you have been testing with before?
So when I was using the greater workload and the others branches that I have when I collected from them, because I needed to remove this for my research project, because it isn't information that I can use, like it isn't public information. I had like a better machine learning model, but because when you have like more information, your model tends to be better, like when you feed this with more information. So yeah, it was a little bit better in performance.
Very cool. Thank you, Andre, for asking all those good questions. I think they indicate quite a lot of interest that we are getting from our audience as well in this area.
Yeah, thanks everyone. Thanks, Angélica, for the great presentation.
Thank you.
If there are no more questions, we can thank our speaker. Thank you, Angélica, for coming over and presenting your work and for answering all our follow-up questions that we had. It was really good to have you today.
Thank you, Bea, for having me here. Thank you all.
Yeah, thank you so
Congrats,
much.
all the
Thank
best
you,
on your
everyone.
PhD.
Thanks.
And for the next month, again, just a reminder, we meet on every fourth Thursday of the month, every last Thursday of the month at 6 p.m. Pacific time. And we'll post our next speaker details shortly on our Meetup page, as well as on our community.o website. So you can check out the details, and would love to have you all join again in the next month as well. Thank you. Bye-bye.